This video covers section 7.3, which is titled Polar Coordinates. And you know, the system of the coordinate system that we're used to is the XY coordinate system, right? We call that the rectangular coordinate system or the Cartesian coordinate system. But in this section, we're going to introduce a new coordinate system. It's called the polar coordinate system. And you can use both systems to locate the same points on a graph. In fact, you can always switch back and forth between polar coordinates and Cartesian coordinates or rectangular coordinates. And so the first video that we're going to cover is kind of going to go over what the polar coordinate system is and how we can switch back and forth mostly, you know, between the two systems, between the system we're used to, the Cartesian system, and the polar system. And then in the next video, we're going to look at graphing some specific polar curves. There's definitely polar curves are different than the curves that we're used to. They're usually more circular in nature. So let's go ahead and talk about this. So first, let's define the polar coordinate system. So you can see the polar coordinate system is still defining some sort of point on the graph, some point x, y. And we're used to saying, okay, well, in order to get to that point, you go over a distance of x and you go up a distance of y. But what the polar coordinate system says is it says, well, no, from the x-axis, you go an angle theta, kind of like the unit circle. So you go an angle theta around in the which direction? That goes in the counterclockwise direction. And then you go out a distance r. So you go out a distance r. All right, so now let's think about this though. So that r, if you look at the r, you can see a right triangle here. Here's the right angle. This side is y, and this side is x, right, for that right triangle. So if we were to think about some of our trigonometric relationships, we can think about, for example, the cosine relationship. We know that with that right triangle, the cosine of theta would be equal to the adjacent side over the hypotenuse, which in this case would be x over r. Now, if you were to go ahead and solve for x, if we were to solve that equation for x, we would see that x is equal to r cosine of theta. And that right there can be used as a formula for converting between polar coordinates and Cartesian coordinates. We could do a similar thing for sine. So we know that sine theta is the opposite over hypotenuse, which in this case would be y over r. And if we solve for y, we would get that y is equal to r sine theta. And so that's the first thing in our theorem down here. When we're converting points between the coordinate systems, the first thing is if we are in the polar coordinate system and we want to know what x is equal to, then x is equal to r cosine of theta. And if we want to know what y is equal to r sine of theta. Okay, and then again, looking at that right triangle, you can see that because it's a right triangle, the Pythagorean theorem holds. So we could say that x squared, leg squared plus leg squared equals hypotenuse squared, or x squared plus y squared is equal to r squared. Okay. We also have a tangent theta formula. We know that tangent theta is equal to the opposite over the adjacent, which in this case is going to be y over x. So the top two equations are for going from polar, this is for converting from polar to Cartesian. And then the bottom two equations, you plug in xy, and you get r and theta. So that's from going from the Cartesian system to the polar system. Okay, so let's go ahead and see how this works. The other thing we did not discuss is what a polar graph looks like. This is a polar graph. You can see the units go outward from the origin. So this circle right here is for r equals 1. And then the next circle around would be 2 units away, that's r equals 2, and so on. And then you can see the angles increase in the counterclockwise direction, and these angles are what we're used to in the unit circle. So, okay, let's go ahead and move on. Example 1, it says convert between rectangular and polar coordinates. The first part says convert each of the following points into polar coordinates. So we're given an x and a y, and we want to find r and theta. So again, using the formulas on the previous page, if we're given x and y and we want to find r, we're going to use the Pythagorean one. So x squared plus y squared is equal to r squared. Well, that means negative 1 squared plus negative 1 squared must be r squared. Well, negative 1 squared is 1, so we have 1 plus 1 is equal to r squared, which means 2 is equal to r squared, which means that r is equal to plus or minus the square root of 2. All right, so that's the first one. We also need to know theta, though, right? So theta is, we can use the other formula, the tangent of theta is equal to y over x, which is negative 1 over negative 1. So that means that tangent of theta is equal to 1, and then we use the inverse tangent. We know that theta is equal to then the inverse tangent of 1. All right, so there's two angles and between 0 and 2 pi where inverse tangent, or the tangent of theta, equals 1. So if you take the inverse tangent of 1, you're going to get two angles. You get pi over 4, and you also get theta equals 5 pi over 4. So let's go back to our original point now to see how this all applies. So negative 1, we know that's in the third quadrant, right? That's in the third quadrant. So if we're talking about graphing this, so here's our XY graph. We can say, okay, well, negative 1 is going to be right here, right? Well, if you describe that with polar coordinates, we know that 5 pi over 4 is the angle, right? This angle here is 5 pi over 4. And so that point there, that distance, this right here, this distance is r. So if we say that we have an angle of 5 pi over 4 with a radius r, or a distance there r, then that point, the polar coordinate, this is the polar coordinate, usually you write r first, so the r in this case is going to be square root of 2, and then the angle is 5 pi over 4. So how can we get the other point, though? So there's 2 points, right? There's two angles that were given. We also had theta equals pi over 4. Well, if we go to pi over 4, and I'm gonna draw the picture and then I'll erase it before we do the next problem. But so here's the picture, and we know that pi over 4 is right here, right? This is pi over 4. But we know our point is over here at negative 1, negative 1. So that's on the wrong side. Well, that's where the negative r value comes in. So if you have an angle that goes to pi over 4, but r is negative, it actually flips it through the origin. So when r is negative, let's draw it on this side, next to the point. When r is negative root 2, we can have an angle of pi over 4, because what that does is it flips this ray over to here, because the r is negative. So that's our point. We actually have 2 points we can use. So most points, actually every point on the graph, we can use 2 polar coordinate descriptions to describe that point, at least. We can actually use more as well, but you know, we listed the 2 that are between 0 and 2 pi, but you could actually use angles outside of 0 to 2 pi as well. So we have those 2 points. I'm going to go ahead and just list that other one over here. So we have negative root 2 comma pi over 4 as our other one. And then we have part B here. So part B says to do the same thing. So go ahead and do part B on your own. Go ahead and pause the video, and we'll come back and talk about it. All right, so if in part B, if we do something similar to what we did in the last one, we know that x squared plus y squared is equal to r squared. X is 0, y is negative 3, so this is 0 plus 9 is equal to r squared, which means r equals plus and minus 3. Okay, and then if you go to our graph, if we were to graph this in the xy coordinate system, we know that 0, negative 3 is down here. Now you could plug in our x and our y in our tangent formula up here. We could plug those in and do that. Here, though, it's pretty obvious, just, you know, knowing the graph, we should know that that angle comes all the way around to here. That's going to be what? It's going to be 3 pi over 2. So our point for this one, when r is 3, we know we have an angle of 3 pi over 2. Now, like we did in the last one, what about if we have a negative r value? Well, if we have a negative r value, then we're going to flip on the opposite side, and that angle is going to only be pi over 2. So that means if we go an angle of pi over 2, right, pi over 2, and then we make r negative, it flips from there to the other side. All right, so those are our 2 points there. Hopefully you're able to get the right answer. And let's go ahead and move on to the second part of this. The second part is convert each of the following points into rectangular coordinates. So now we're going to go the opposite way. So we have 6 comma 2 pi over 3. Well, the 6 is r, so r equals 6, and the theta is equal to 2 pi over 3. And so we're going to use our 2 formulas. We know that x equals r cosine theta, and then y is equal to r sine theta. Y equals r sine theta, and we plug in those values. So we get here 6 times the cosine of 2 pi over 3. And then when we do that, we know that the cosine of 2 pi over 3 is negative 1/2. So this is 6 times negative 1/2, which is what? Negative 3. So x is equal to negative 3. And then over here we have 6 times the sine of 2 pi over 3. And the sine of 2 pi over 3 is root 3 over 2. So this is 6 times root 3 over 2, which is 3 root 3. So our answer here is going to be that x is negative 3 and y is 3 root 3. That's our y value. Okay, so I did part A. You go ahead and do part B on your own. Pause the video. Okay, great. Let's go ahead and talk about the solution for B. Hopefully you're able to get that right. Again, x is going to be equal in this case to 2 times the cosine of 3 pi over 2. If we do that, we get 2. Cosine of 3 pi over 2 is 0, so we get x equals 0. And then y is equal to 2 times the sine of 3 pi over 2, which is equal to 2 times -1, which is equal to -2. So our answer in this case is that x is equal to 0 and y is equal to -2. There's our point. Okay, so that's kind of how we convert points between the two systems. Let's go ahead and talk about plotting them now. So plot each of the following points on the graph. Example 2. So if we go to an angle of pi over 2, we know pi over 2 goes 90 degrees, and then a distance r of 3, 1, 2, 3. It's going to be right there. That's the point 3 pi over 2. Okay, we can also go to pi over 3. Pi over 3 is this ray right here, right? There's pi over 3, but the distance is -1, so we have to flip to the opposite side. We're going to flip to this side because it's a negative r value. So this is -1 pi over 3. Okay, then we have -2, 3 pi over 4. So if we go over to 3 pi over 4, then because it's -2 again, we flip to the opposite side, which is 7 pi over 4. So it's right there. That's -2, 3 pi over 4. And then the last one is -pi over 4, 2. So now -pi over 4, we go in the clockwise direction. So we go basically pi over 4 clockwise, which actually is the same as 7 pi over 4, right? -pi over 4 is the same as 7 pi over 4. And an r of 2, that's actually the same point we just plotted. So that same point could also be the point 2 pi over 4. All right, both of those describe that same point. That's how we plot points in the polar coordinate plane. That's going to do it for this video. When we come back, we're going to look at graphing some different polar curves and also converting between converting equations between the two coordinate systems. So let's go ahead and end this video. I'll see you in the next video. Thank you.